So picture this. You are standing in a massive, just a cavernous train station, or maybe, one of those trendy new restaurants with the exposed concrete ceilings and hardwood
Oh,
floors.
yeah, an absolute acoustical nightmare.
Exactly. And someone is making an announcement over the speakers, and it is just this wall of muddy, echoing noise. You can't understand a single word.
Yeah, that happens everywhere.
Right, so today's deep dive is about the exact piece of technology designed to fix that specific problem. We are translating the technical specs of the QSC AD-S162T-WH Acoustic Design Series loudspeaker.
That is quite a mouthful.
It really is, but we want to find out why it commands a $1,296 price tag.
Well, looking at the physical footprint of this unit, it immediately subverts what you expect a PA speaker to look like.
Yeah.
We are dealing with a 26-pound aluminum column that stands nearly 4 feet tall.
Okay, let's unpack this, because the inside of that massive column is where the engineering actually gets interesting. It packs 16 individual 2.75-inch paper drivers just stacked right on top of each other.
Right, right.
And when you arrange that many small drivers vertically, you aren't just building a louder box, you are fundamentally changing how the sound travels. Right. Instead of an audio bomb going off in all directions, it acts much more like, well, a high-tech sound laser.
Yeah, what's fascinating here is how that laser shapes the audio. The dispersion pattern is incredibly specific.
How specific are we talking?
So it throws sound 160 degrees wide, meaning, it covers the whole room horizontally, but the vertical spread is compressed down to a mere 15 degrees.
Wait, only 15 degrees vertically?
Exactly.
Which directly solves that echoey train station problem we started with.
Yeah, it does.
Because if the audio beam is only 15 degrees tall, those sound waves are firing straight at your ears. They never have the chance to hit the high ceilings or bounce off the hard floors.
Right, eliminating all those acoustic reflections that cause muddy reverb in public spaces. That vertical control really is the defining feature of the hardware. But, it introduces a massive logistical headache for the people installing it.
So what does this all mean for actually putting it on a wall? If the sound beam is that narrow, aiming it becomes critical, right?
Extremely critical.
You can't just bolt a rigid 4-foot metal column flat against a wall 10 feet in the air and expect it to magically hit the audience.
No, you definitely can't.
But then on the flip side, putting a 26-pound speaker on a giant, bulky, articulating arm so it sticks out awkwardly into the room, well, that completely ruins the sleek aesthetic of modern architecture.
Which is why QSC bypassed that trade-off with a highly specialized pan and tilt mounting system. It's actually pretty clever.
Oh, really? How does it work?
Well, the speaker itself remains completely flush and unobtrusive against the wall, but the hidden bracket mechanism allows for a negative 20-degree downward tilt. So you get the pinpoint targeting of that narrow sound beam without, sacrificing the visual design of the space.
That is wild. So the hardware physically shapes the sound and blends into the room aesthetically. But commercial audio gear also has to survive brutal physical environments. It's not just sitting in a cozy living room.
Right. And it is over-engineered for exactly that reason. The unit has an IP54 rating.
Which means dust and splashes, right?
Yeah, it's highly resistant to both. Pair that with the powder-coated aluminum chassis and weather-treated cones, and this column is equally functional on a humid, uncovered restaurant patio or, deep inside a dusty warehouse facility.
It's built to survive physically, but it also has to survive on the building's network. And I know a lot of people see 70-volt or 100-volt system on a spec sheet and their eyes just glaze over.
Oh, absolutely. It's totally jargon.
But this is actually crucial for massive venues.
Yeah.
If you try to run standard speaker wire across a giant airport terminal, the natural resistance of the copper wire causes a massive loss of power over those miles of cable.
Exactly. Stepping the audio signal voltage up to 70 or 100 volts solves that voltage drop.
Right.
It allows an installer to daisy-chain dozens of speakers across thousands of feet of cable on a single run without losing volume.
And if you're just wiring a smaller space, you can bypass that transformer entirely, right? You just run it as a standard 8-ohm speaker. It's kind of like a universal power adapter that just plays nice with almost any commercial sound system.
Yeah, that's a great way to put it. So bringing all those specs together, it's really a 200-watt problem solver pushing 112 decibels of highly targeted audio.
Wow.
And for anyone actually sourcing these for a project, there's a vital detail buried in the documentation.
Oh, I love the hidden details. What is it?
The standard warranty is 3 years, but you can instantly double it to a 6-year warranty simply by registering the product online. It's a huge risk reduction for a commercial investment.
Getting 6 years of coverage just for filling out a form is a brilliant tip. So we've explored how this column uses physical scale to focus audio into an incredibly narrow, precise beam,
We have, yeah.
and it really makes you wonder about the future of architectural sound. As surface mount speakers get even better at aiming audio like a laser, how close are we to a world where public sound systems become entirely personalized and invisible?
That is a crazy thought.
Right. Just imagine walking through a busy, massive art gallery where a localized sound laser follows just you, delivering an immersive private audio tour without you ever needing to wear headphones. It's a completely different way to experience the architecture around you.